Hello students, welcome to Power Classes. So today we are going to revise chapter 11, which is areas related to circles. So in this chapter we are going to find areas with respect to sector as well as areas with respect to segment. So what is a sector? Suppose this is a circle here and this is a center, and if you mark this point, so this area will become a sector. So the smaller portion, so it is minor sector, whereas the remaining entire portion will become major sectors. The same way, if in a circle a line is, that is a chord is drawn, and the area which is smaller part which is called as minor segment, whereas the larger segment we call it as a major segment. So in this chapter we will find how to find the areas of these sectors, minor as major, as well as the areas of minor and major segments. Okay, so before that, how to find the area of a sector of angle theta. So the formula is theta by 360 into pi r square. So you can also understand that pi r square is area of circle, whereas theta is the angle drawn here. For suppose this is a sector here, so then this angle will become theta. So the part of total 360 into pi r square. It is similar to, suppose this we have a square here and there is 1/4 portion. Then what is area of this 1/4 portion? We say that the shaded portion by total portions into total area square. Same way, the total area of circle is pi r square. So in that pi r square, what is the shaded portion? This part. The total angle is 360, whereas this part is theta. So theta by 360 into pi r square. So in this way, this formula will be defined, that is the area of sector of angle theta. Whereas how to find the length of arc of a sector of angle theta, that is this, they want to find the length of this arc. So how to find length of this arc? The formula is theta by 360 into 2 pi r. Here 2 pi r, if you consider, the 2 pi r is the circumference of a circle, that is this total length. The same way how we are finding for radius, same way the logic, that is the angle theta by total 360 into 2 pi r, the total circumference. So in this way the angle length of arc of a sector can be defined, whereas area of major sector is simple, that is total area minus the minor area. You can also say that total angle is 360, so to 360 minus theta by 360 into pi r square. So okay, so let's go with area of segments. So consider this is a circle, this is a sector, and this is a segment here. So area of segment can be found out by area of this sector minus area of this triangle. We'll get this shaded portion. So area of sector equal area of sector OAB minus area of triangle OAB. So the formula of sector we already know, that is theta by 360 into pi r square, and the area of this triangle can be found out by using half into sine theta into pi r square. So you have to remember this. How to find the area of a triangle? If angle is given inside a circle, then the area of triangle is half into sine theta into r square. Okay, so let's go with exercise. So here in the 11.1 exercise, we have find the area of sector if radius is given and theta is mentioned. So direct formula, area of sector equal to theta by 360 into pi r square. So in the question, if they mention consider pi as 3.14, then you can have to consider pi as 3.14. If they didn't mention what is the area of pi, value of pi, then you can also directly write as 22 by 7. So theta by 360, that is 60 by 360 into 22 by 7 is 6 into 6. So 6 and 6 got cancelled, and 60 by 360 we got 6. So in this way, if you do the calculation, you'll get 132 by 7 centimeters square. So I suggest you, if you don't have time to calculate into decimals and give it like this, then also you'll get a full marks. Okay, so let's see that second question, that is third question here. So here they have mentioned minute hand length is 14 centimeters. Find the area left in 5 minutes. So suppose this is a clock here, and they are asking only for the minute hand. So you can consider the minute hand length as the radius, which is 14, and they are asking area left in 5 minutes. So what is total minutes in hour? It is 60 minutes. So 60 minutes is the entire rotation. So 60 minutes equal to 360 degrees. 5 minutes, how many degrees? So 60 by 5 equal to 360 by x. 6 1 is 6 6 are, then x will become 5 into 6, that is 30 degrees. So we got theta angle here, which is 30 degrees. So for 5 minutes means it will be like this. So it will be in this part. Okay, so this angle is 30. They are asking to find the area of this one, so it will be theta by 360 into pi r square, that is 30 by 360 into pi. As I mentioned, if they didn't mention in question 3.14, then you have to mention it as 22 by 7 and into 14 we'll get the final answer as 154 by 3 centimeters square. So we found area of sector, and this is a practical scenario. Like there is a clock, there is a minute hand, they are asking to find the total area served for 5 minutes. So for 5 minutes, what is the angle, we figured it out. Then using that angle, finding out the area. If they ask what is the length of the minute hand it is covered, that is length of arc, then the formula is theta by 360 into 2 pi r. If you follow this formula, we will get a length. So based on the question, if they ask length, then you have to follow this formula. If they ask area, then you have to follow this. Let's see other type. For the segment type questions, how we have to solve. So I'm taking an example of 7th question here. So in the 7th question, we can see they have provided radius. They have provided chord, subtends and angle 60 degrees here. That is, this angle is 60 degrees. At center, find the area of minor and major segments. So for this type of questions, first we have to find what is the sector area, and then what is the triangle area, and then we have to subtract, then we'll get a minor segment. For the major segment, it's simple, that's total circle area minus this this part, the sector minus segment area. So first, to find area of minor segment equal to area of sector minus area of triangle. Area of sector we already know, it is theta by 360 into pi r square. Area of triangle, which I already explained in the first page, that is area of triangle in a circle. If you find out, then it will be half into sin theta into r square. So the same formula I have written here. Theta is mentioned already in the question, that is 60 degrees. So 60 by 360 into 22 by 7 into r square, that is 15 into 15 minus half into sin theta. Theta is mentioned 60 into 15 into 15. For sin theta values, we already explained in the trigonometry chapter. So if you are new to this new to my videos, let's suggest you to check the trigonometry chapter. There I have mentioned how to remember all the sine, cos and tan, cosecant, all trigonometry values. Also I have mentioned another video where I can convert from sine to any other values as well. So using, better to suggest that, or else you have to remember at least 0, 30, 45, 60 and 90 degrees. Then we can solve any type of questions. Okay, so sin 60 we already know, it is root 3 by 2, as I directly mentioned. So 60 by 360 is 1 by 6 into 22 by 7 into 225 minus half into sin 60 is root 3 by 2 into 15 into 15. Then solving this question, we will get the final area of minor segment as 22.4375 centimeters square. Area should always be mentioned in centimeter square because it is a multiplication of two values, that is side into side. Next, for area of major segment, the area of major segment we already know, that is total circle minus minor segment, we will get a major segment. So total circle area is pi r square minus the formula value which already mentioned. So 22 by 7 into r square, that is 225 minus 21,438. Solving this, we will get the final answer. So in this way, segment areas can be calculated, that is minor and major. If you found the minor, simple, the total circle minus minor segment will get the major segment. Whereas for sector, you have to follow these formulas, that is theta by 360 into pi r square. And if they are mentioned in a practical scenario, you have to consider what is the angle and then use the formula. So in this way, I can conclude the revision of 11th chapter, that is areas related to circles. So if you have any doubts with respect to circles in this chapter, if you want any solution of any other question, kindly mention in comments so that I can also prepare another video. If it is similar, then I will just mention the points how you can solve it. So if you like the video, please like, do comment for any questions as I mentioned, and also if you want to post any question or post any photograph for any doubt, you can also join my Telegram link which I have mentioned in the description so that I can check and solve it accordingly. So let's meet with the 12th chapter. Thank you.